These are some review questions from chapter 4. 4.7, number 3. Okay, the product of two numbers is 100. X times y is 100. You're trying to minimize x plus y. Well, if I divide here by x, y is 100 over x. So f of x is x plus 100 over x. I'm trying to minimize this where x and y are both greater than 0. So I rewrite it as x plus 100, x to the negative 1. F prime of x is 1 minus 100, x to the negative 2. Double prime is 200, x to the negative 3, which is 200 over x cubed. That's greater than 0 for all x greater than 0, which means I have a concave up situation, which is a minimum. So I set f prime equal to 0. 1 minus 100 over x squared equals 0. Multiply both sides by x squared. X squared minus 100 is 0. Add 100, take the square root. X is 10. I don't need plus or minus. I only want positive. And y is 10. So 10 and 10 are the two numbers involved. Okay. Number 7, you're given the perimeter is 100, x and y. So 2x plus 2y, formula for perimeter, is 100. You're trying to maximize the area, which is x times y. Solve for y. Y is 100 minus 2x over 2, or 50 minus x. Plug that back into here. So my area function, a of x, is x times 50 minus x, which is y. 50x minus x squared. I'm trying to maximize this with x greater than 0. So a prime is 50 minus 2x. Double prime is negative 2. That's less than 0, which means concave down on a graph, which means I have a maximum. So I set 50 minus 2x equal to 0. X is 25. Y is 50 minus 25, also 25. So the dimensions are 25 meters by 25 meters. In 4.1, f of t is 2 cosine t plus sine of 2t on the interval from 0 to 2. Okay, so we're looking for max and min. F prime of t is negative 2 sine t plus 2 cosine 2t. Okay, change this to cosine squared minus sine squared. Distribute negative 2 sine t plus 2 cosine squared t minus 2 sine squared t equals 0. I need to have just one trig function, so I'll change cosine squared to 1 minus sine squared t. Distribute minus 2 sine t plus 2 minus 2 sine squared t minus 2 sine squared t is 0. Combine like terms. Negative 4 sine squared t minus 2 sine t plus 2 equals 0. Factor out the negative 2. And factor some more. So this gives me sine of t is a half, or sine of t is negative 1. We only have angles between 0 and pi over 2. So this can't happen. So this gives me pi over 6. F of 0, I choose the endpoints, 2 cosine 0 plus sine of 0, 2 plus 0, 2. F of pi over 6 is 2 times radical 3 over 2 plus radical 3 over 2, which is 3 radical 3 over 2. That's about 2.6. F of pi over 2 is 0 plus 0 or 0. So absolute minimum is 0, 0. Absolute max at pi over 6, comma 3 radical 3 over 2. Here's 4.4, number 57. Limit x approaches 0 from the right of x to the radical x. So let y equal x raised to the radical x. Find limit x approaches 0 from the right of y. So let y equal x radical x raised to the radical x. Take the natural log of both sides. Ln y is radical x ln x, which is ln x over 1 over radical x. Now limit x approaches 0 from the right of ln y is limit x approaches 0 from the right. This is infinity over infinity. When x approaches 0 from the right, the top goes to negative infinity, the bottom goes infinity. So L'Hopital's rule applies. So take the derivative of the top, 1 over x. The bottom is x to the negative 1/2, whose derivative is minus a half x to the negative 3/2. There's a negative there. Clean it up, dividing by negative a half is the same as multiplying by negative 2. X to the 3/2 on top, 1 over x in the bottom. Take out the negative 2. Negative 2, limit x approaches 0 from the right of radical x. This is 0, 0 times negative 2 is 0. So limit as x approaches 0 from the right of ln y is 0. Exponentiate both sides. So limit as x approaches 0 from the right of y is 1. 4.2, number 5. Okay, f of x is 2x squared minus 4x plus 5 on the closed interval from negative 1 to 3. This is a polynomial. It's continuous everywhere. Therefore, it's continuous on bracket, negative 1, 3 bracket. Differentiable on parentheses, negative 1, 3. Okay, f of negative 1, plug in negative 1. Get 2 times negative 1 squared minus 4 times negative 1 plus 5. That's 11. Plug in 3, 2 times 3 squared minus 4 times 3 plus 5. It's also 11. Okay, so Rowe's theorem applies. There's a c, but somewhere between negative 1 and 3, such that f prime of c is 0. Find it. So the derivative comes out to be 4x minus 4. Solves equals 0, x equals 1, which is between -1 and 3. So the c that they're looking for is equal to 1 in this particular case. Okay, let's see. 4.7, number 4. X and y both positive equals 16. Minimize x squared plus y squared, the sum of the squares. So y is 16 minus x. And so generally you're trying to solve for the variable that is in x. So f of x is x squared plus y squared. So I want to minimize this quantity. F prime is 2x plus 2 times 16 minus 6 times -1. That's 2x minus 32 plus 2x, 4x minus 32. Double prime is 4. Okay, that's greater than 0, which means I will have a minimum. Set f prime of x equal to 0, 4x minus 32 equals 0. X is 8. Plug back in, y is also 8. Okay. And the sum of the squares is 8 squared plus 8 squared. Final answer is 128. Number 8, x by y, the area is 1,000 meters squared. Minimize the perimeter. So x times y is 1,000. Perimeter is 2x plus 2y. You're trying to minimize this. Y is 1,000 over x. Plug that back into here. So I have 2x plus 2y, 1,000 over x. So that gives me 2x plus 2,000 over x. I'm trying to minimize this with x greater than 0. We write as 2,000 x at -1. So p prime is 2 minus 2,000 x at -2. Double prime is 4,000 x at -3rd, which is equal to 4,000 over x cubed. X cubed, that's greater than 0 for all x greater than 0. That means I have a concave up situation, which means I will have a minimum. So set f p prime equal to 0. 2 minus 2,000 of x squared equals 0. Multiply both sides by x squared. Subtract the 2,000. Divide by 2. And the screen is frozen, so I have to stop for a moment, unfortunately. And try to get it back. Without restarting the video. I think we're back in business. So let's see where I was here. Divide by 2, x squared is 1,000. Take the square root. Forget the plus or minus, just a plus. So x is the square root of 1,000, which is 100 times 10. 10 radical 10, about 31.62 meters. Y is 1,000 over x, so 1,000 over 10 radical 10 is 100 over radical 10 multiplied by radical 10 over radical 10. That's also 10 radical 10, which is also 31.62 meters. So basically, x by y, 10 radical 10 by 10 radical 10 meters, it is a square that we're looking at. 18, we have $10 a foot. No fence here. $20 a foot, $20 a foot. We have $5,000, maximize the area. So the cost is 10x plus 20y plus 20x. That's 30x plus 20y. That equals 5,000. Maximize x times y. Y is equal to 5,000 minus 30x divided by 20, which is 250 minus 3 halves x. So the area function is x times y, 250 minus 3 halves x, or 250x minus 3 halves x squared. Maximize this, x greater than 0. So a prime is 250 minus 3x. A double prime is -3. That's less than 0. That means concave down. That means I have a maximum. So set a prime equal to 0. X is 250 over 3, or 83 1/3 feet. Y is equal to 250 minus 3 halves x, 125 feet. So the dimensions are 83 1/3 feet by 125 feet to maximize the area. 4.7. So you have 10 feet of wire. Make a cut, call one side x, the other 10 minus x. You bend one into a square. So if I bend this into a square, it's 10 minus x over 4. The other is an equilateral triangle. So I bend x into x over 3, x over 3, x over 3. Okay. First, we need the formula for the area of an equilateral triangle. Okay, so I call this S, S, and S. Draw the height here. This is half S. Pythagorean theorem, h squared plus half s squared equals s squared. H squared plus square this, you get 1/4 s squared. Subtract 1/4 x squared, you have h squared is 3/4 s squared. Take the square root, h is the square root of this, which is s radical 3/2. So the area of the equilateral triangle is 1/2 base times height, 1/2 s times the height, s radical 3 over 2, s squared radical 3 over 4. All right, with that in mind, my area function a of x is the area of the square. One side was 10 minus x over 4. So 10 minus x over 4 squared, plus my new formula for the area of an equilateral triangle is x over 3 squared radical 3 over 4. So this can be rewritten as 1/16 10 minus x squared plus x squared radical 3 over 9 times 4, 36. So I'm trying to maximize and minimize on a closed interval between 0 and 10. So I plug in the two endpoints. Plug in 0, that means it's all square. I get 100 over 16 or 25 over 4, 6.25. If I plug in 10, it's all triangle. 10 squared radical 3 over 36, 25 radical 3 over 9, 4.81. So that's all triangle. Now I take the derivative, 1/8. So I'm taking the derivative of my area expression right here. So it's 1/8 10 minus x times -1 plus x radical 3 over 18, set it equal to 0. Okay, -1 times that is x minus 10 over 8 plus x radical 3 over 18 equals 0. Multiply both sides by 72, common denominator. 9 times x minus 10 plus 4x radical 3 equals 0. Distribute. Move the 90 over. Factor out the x, 9 plus 4 radical 3. X equals 90 over 9 plus 4 radical 3. That's about 5.65. If I plug that in, I get an area of about 2.72. Okay, so I look at my critical numbers and my endpoints. So the maximum is when x is 0. That means it's all square. A is 6.25 meters squared. The minimum occurs at x equals 5.65. So you cut 5.65 across, and that area will be 2.72 meters squared. Okay, here's a 4.545, y equals 1 over x plus ln x. That's x at -1 plus ln x. The domain is 0 to infinity. Intercepts, you cannot have x equals 0. And 0 equals 1 over x plus ln x. We can't solve. Okay, so we can't say for sure what's going to happen here. We will get an intercept a little bit later, though. Okay, happens. Well, we'll see later. Okay, symmetry, there's no symmetry. Asymptotes, when x approaches infinity, y approaches infinity. X approaches 0 from the right. Well, I can rewrite this as limit x approaches 0 from the right of common denominator 1 plus x ln x over x. I need to know what happens to this limit. So limit as x approaches 0 from the right of ln x over 1 over x. That's x at -1. This is infinity over infinity. So L'Hopital's rule applies. Limit x approaches 0 from the right of 1 over x divided by -x at -2. Rewrite as so. That limit is indeed 0. Okay. So essentially, this approaches 0. 1 plus 0 over a very small number, so that approaches infinity. Okay, so I have a vertical asymptote at x equals 0 for the y-axis. Okay, y prime is this, which I can rewrite as -x at -2 plus x at -1, or -1 over x squared plus 1 over x. Second derivative is 2x at -3 minus x at -2. Rewrite it as that. Set y prime equal to 0. Set this equal to 0. I get -1 equals plus x equals 0, or x equals 1, 1 comma 1. Okay, this should be 1, 1. Okay, then do a sign chart. Plug in 0 or a number a little bit bigger than 0, like 0.1. It'll be decreasing. And number bigger than 1, it's going to be increasing. It'll be positive. Okay, so f is decreasing from 0 to 1, increasing from 1 to 0. 1, 1 is the minimum. So that clinches that this graph never touches the x-axis. Y double prime equals 0. Here's double prime multiplied by x cubed. 2 minus x equals 0. X is 2. Plug back into the original. 1/2 plus ln 2. That's the exact value. It's roughly 1.193. Sign chart. Okay. If I plug in 1, I get 2 minus 1, that's positive. Plug in 3, this is 2 over 27 minus 1/9, that's negative. So concave down. So the function is concave up from 0 to 2, concave down from 2 to infinity. So 2 comma 1/2 ln plus ln 2 is an inflection point. So here we go. decreasing to 1, 1, absolute minimum, increasing, concave up, inflection point, concave down the rest of the time. Okay, 4.445, find this limit, sine 5x cosecant 5x. Cosecant 3x means I can put sine 3x in the bottom. Okay, that's 0 over 0, so L'Hopital's rule applies. So the derivative of the top is cosine 5x times 5. Likewise, the bottom is 3 cosine 3x. Plug in 0. That's 1, so you have 5 over 3. 47, limit x approaches infinity of x cubed over e to the x squared. That's infinity over infinity. L'Hopital's rule applies. Derivative of the top is 3x squared. Derivative of the bottom is 2x e to the x squared. After canceling, I get 3x over 2 e to the x squared. That's still infinity over infinity. So L'Hopital's rule applies again. So I get limit x approaches infinity 3 over 2 times 2 e to the x squared times 2x. Okay. And now when x gets big, the top stays 3, the bottom gets big, so the ratio is 0. 55, limit x approaches infinity of x minus ln x. The trick here is to multiply top and bottom by x, and then split it into 2. I have limit x approaches infinity of x times limit x approaches infinity of x minus ln x over x. I can rewrite this as 1 minus ln x over x. So I have limit x approaches infinity of x times limit x approaches infinity of 1 minus limit x approaches infinity of ln x over x. I can do L'Hopital's rule over here. So I have limit x approaches infinity of x times 1 minus limit x approaches infinity 1 over x divided by 1. This approaches 0. So I have the limit x approaches infinity of x times 1, and that's just infinity. Limit x approaches 0 from the right of x to the radical x. Again, call this y. So you're ultimately trying to find limit as x approaches 0 from the right of y. ln both sides here. Radical x comes down. What you're going to write is ln x over 1 divided by radical x. This is a negative infinity over positive infinity case. Take the limit as x approaches 0 from the right. So differentiate the top, 1 over x. Differentiate x at negative half. That's negative half x at negative 3 halves. Bring this up. Divided by negative half is the same as multiplying by negative 2. So that gives me x at 3 halves over x. That's limit x approaches 0 from the right of negative 2 radical x. That's 0. So limit as x approaches 0 from the right of ln y equals 0. Exponentiate. I have limit as x approaches 0 from the right of y, or limit as x approaches 0 from the right of x to the radical x. That's equal to 1. 63. Limit as x approaches infinity of x raised to the 1 over x. Same strategy, call this y. So you're looking for limit x approaches infinity of y. Take the ln of both sides. 1 over x comes down, which means I can write it like that. Limit x approaches infinity of ln y. Limit x approaches infinity ln x over x. That's infinity over infinity. L'Hopital's rule applies. Limit x approaches infinity of 1 over x divided by 1. That's 0. So I have the limit as x approaches infinity of ln y equals 0. Exponentiate. So limit as x approaches infinity of y, which is ultimately what I'm looking for, is equal to 1. Okay. And let's see, one more, 4.8, number 6 on Newton's method. 2x cubed minus 3x squared plus 2 equals 0. First guess is negative 1. Okay, so here's the function. Here's its derivative. x2 is x1 minus f divided by f prime. So that's negative 1 minus, plug in negative 1 here, 2 times negative 1, minus 3 times 1 plus 2, divided by the derivative, 6 times negative 1 squared minus 6 times negative 1. Okay, now if you have the answer button, you can do the shortcut that I showed you before. But if you do not have the shortcut, that's okay. You can still do it. It's a little bit more cumbersome. It's negative 1 minus negative 3 over 12. It's negative 1 plus 1/4, negative 3/4, or negative 0.75. Okay, then for x3, you do the same thing. Negative 0.75 minus, plug in negative 0.75 to the top and bottom. So negative 2, negative 0.75 cubed minus 3 times negative 0.75 squared plus 2 over 6 times negative 0.5 squared minus 6 times negative 0.75. Punch it in the machine. X3 is negative 0.6825. So it's clearly more clumsy if you don't have the answer button, but it's definitely possible still to do. Okay, so those were some review questions in preparation for the test for chapter 4.